Welcome back to Soil and Arthropod-borne diseases. Our next section, we just finished talking about tetanus, where you can get this from the soil and have deep tissue wounds. This is another deep tissue wound called gas gangrene, and it is caused by a bacteria we already have heard of, Clostridium perfringens, that can also cause a foodborne illness. It can also cause infection of the intestinal tract, causing this black bowel disease. And this means there is necrosis in the tissues there, and this intestinal tract will surely die. This is an example in a mouse, actually, thankfully. But this gas gangrene is an extremely dangerous organism to have. It is gram positive. It grows in deep tissue because Clostridiums are anaerobic. You can get it through a puncture wound. You can get it through loss of blood flow. You can get it through um, a deep tissue damage, such as a bruise sometimes, because there are cracks that can go all the way down through the tissues to get an infection. The problem is it produces a large amount of toxins and enzymes that will kill the tissue around it, causing necrosis. So these tissues around the infection will not have any blood flow. So the lack of blood flow means that the immune system has a very hard time getting to it and stopping the infection. And on top of that, you cannot put in antibiotics to basically clear out the infection because that needs a blood system to bring it to the correct area. So you'll get this necrosis where there is blackening of the tissues and usually loss of that tissue later on. And of course, if you get intestinal, that basically means that it's extremely dangerous. Now, this myonecrosis or blocking of the blood flow makes it very difficult to treat. So a lot of what will happen, I do not show these pictures, is called debridement. You cut away the dead tissue so you can get blood flow to that area. And in the case of this leg, you can see deep tissue bleeding because basically it's causing necrosis and pooling of blood, and these large bubbles are showing up. Uh, Gas gangrene is called this because with deep tissue wounds, it will actually produce a gas for fermentation because it's anaerobic. And it has been recorded and known that if you do not catch this in time, um, sometimes surgical wounds, but definitely tissue will explode outward because of the pressure of gas in it. So one of the treatments is to flay this open almost to the bone and sometimes to the bone to expose this to air. And we'll put a little oxygen tent over this and increase the oxygen in this area to kill the Clostridium. This person most likely will have this leg amputated because of the extreme nature of this gas gangrene. This is not the worst tissue picture of there. However, the CDC even has some pictures on what a good wound versus a bad wound is. You have stitches here. It's not swollen. It's not red. When you have a wound that has redness, tenderness, swelling, you even have streaks of red going from it, that is a wound you definitely need to get checked out. This is an example from one of the nursing students whose mother had some vein surgery here, and it got gangrenous, especially on the toe. You see necrosis here. You see a gas building up in the heel, and they actually had to cut it open a couple of times to relieve the pressure and expose this to air. She recovered because of fast reaction on the treatment. And they exposed it to a hyperbaric chamber, basically the oxygen tent. Between that, antibiotics, and a little bit of debridement, she is living today. And I got permission to use these pictures because of somebody who loved microbiology as much as I did, even though it was their mom. So gas gangrene is a bad thing. Um, my This is an important thing to look out for with abscesses and deep tissue wounds and bed sores. My grandfather died of a gas gangrene because of the lack of moving him at the nursing home or the recovery home that he was at. They didn't notice there was fist size necrotic holes in his backside, and by that time the gas gangrene had spread so quickly that he had less than a week to live because of lack of appropriate care. Now, one disease that you will not usually see in the U.S., hopefully, is leptospirosis. It's a very dangerous disease. It causes not only headache, fever, red eyes through a conjunctivitis. So that's a nice little special uh, symptom of it. Basically, you have extreme liver damage, you can have kidney damage. And when I say kidney damage, your glomerulus starts allowing bleeding. Your kidneys shut down because there is so much damage to your nephron units that you're bleeding out through your kidneys, and your kidneys die. As the extreme example with this one, you cannot even see where the renal pyramids are really because the nephron units are so destroyed. This is a spirochete, and this spirochete is spread by animal urine. And this organism is usually associated with places that associate with animal urine more. So you can see this in the homeless and very low income areas of the US, but you usually see this more in Africa and developing countries because of their close proximity to animals. There has been a number of outbreaks in Africa in villages for various reasons. I am going to talk about a very interesting bacteria at this point. This is an arthropod-borne bacteria, and I'm going to split up the arthropod-borne diseases after this because this one requires some special study. Arthropod means insect-borne for the most part. It isn't completely all insects, but arthropod means exterior shell or exoskeleton, which covers all the insects, but there's more animals than that. Now, this is uh, a time versus population in the millions of people. We have recorded history, and then we have this dip down in the 13th and 14th century where we have maybe a loss of 50 to 100 million people at our best estimate. But that was a considerable amount of the world population at that time. And it was all due to something called, Yersinia pestis. And here is an excellent example of the world and social strife that was happening in Europe at the time of the plague. They did not understand it was caused by bacteria. You have people wrapped or dead people wrapped in cloth here, just lying in the street. They're all over the place. There's carts of dead here, which is why the Monty Python Bring Out Your Dead skit is actually very appropriate historically for that time. We have people carrying dead out in droves. We have people panicking, praying, not knowing what to do, and the medical personnel not knowing what to do, people dropping in the streets. We have something, a red raised welts in them called buboes that were just showing up a neck, armpits, groin, whatever. We have people saying rites, not knowing what to do, but just praying to God because there was nothing else to do. This was an extremely chaotic time that changed society to its very core in Europe and other places. It wasn't the only time we had the outbreak, but this was a major um, effect on life and society and culture as we knew it. But out of his came the Renaissance and a different government style, which eventually led to democracy, but it was a long and bumpy road. Yersinia pestis, which caused bubonic plague, is a gram negative rod. It doesn't really look like that here, but it's actually pink versus the purple. It is spread by arthropods. It is not its only route. I have to be clear about that. It's primarily arthropod-borne disease, but it is also spread by air. So this is an extremely dangerous bacteria. It's only one of a few that actually cause pandemics or worldwide infections, and I'm sure everybody knows what that is now. It has been due to its symptoms, which are very clear. We believe it caused the Justinian plague of 541. The best estimates are about 25 million people died there. And this, along with a couple other major outbreaks, is probably the reason, or definitely helping the reason of the fall of the Roman Empire, the main Roman Empire. We have the Great Plague, which was the Black Plague in the 1300s, mid 1300s. And this went on for a number of decades, where it is estimated, a low estimate, and it's probably not correct, 30 million. More accurately, probably is 100 million people died in that. So about 60% of all Europe died due to this. So it really puts ours in perspective right now. And then we had a moderately low amount of people die in the modern plague, 1860 to about 1880. We only had about 10 million people die, and this was a pandemic. It caused first an outbreak in China and Japan, and then Europe. But at about the same time, the U.S. got hit pretty hard, especially in the Californian side of things, and that was just due to who was considered a expendable worker class at that point. Unfortunately, this is what Yersinia pestis looks like on blood auger or sheep blood auger plates. It causes alpha hemolysis. It's a gray, milky white colony with these translucent edges. It's kind of pretty when you look at it, but you don't want to look at it too close. And we always use it underneath the hood. We use it in BSL-2, if not 3 conditions, unless it has been majorly neutered for toxins. The transmission, the lowly flea. This flea can jump many times its own body length and is usually found in rats, cats, and dogs. So a lot of things that are around humans, rats and mice and such, are usually around humans when there is low conditions of health. But we can also have other rodents, squirrels, whatever those are, and prairie dogs carry this. And prairie dogs are the main way that U.S. Uh, exposure happens, especially in the Four Corners region. But I would like to point out that we have this flea cycle where it'll bite and bite rats or rodents and get a blood meal from them, and thus the fleas are infected. But the fleas are not finished there. They'll bite again and again and again. So if you bite to a human and spread to another human, you can infect a lot of humans. We have Yersinia pestis detected in rats in the subways of New York City and found over in San Francisco. So the question is why we haven't had it to humans yet is because of high public health standards, or at least relatively. But the question is, well, if the flea needs this blood meal to mature and have eggs laid, it should only need one blood meal. So why is it biting, jumping and biting to so many people? Please note that later on we're going to have to talk about the pneumonic route and the bubonic route, but for right now we'll talk about the arthropod. Okay, so the flea bites more than one person. The question is why. Somebody answered this in the pathogenic micro field, which was pretty fun to read about in the Yukon journals. This is a regular flea who has gotten a blood meal. This is not the actual size. It's actually smaller than that. But this blood meal will go into the midgut, and going from this little tube, you can see actually it goes in, and then it has this narrow opening here that goes to the midgut. This is a Yersinia pestis infected flea. You can see that the red here of the blood stops at the very top of the midgut and does not go in because the mass of Yersinia pestis is there. So the Yersinia pestis actually blocks the flea from getting a blood meal, so makes it ravenously hungry. So it's jumping and biting, and it'll regurgitate a little bit of the Yersinia pestis into a wound. It'll jump and bite again, jump and bite again. So it spreads because it can never be full or satiated for food and complete its life cycle. There is a specialized colonization factor, a couple genes that when knocked out of Yersinia pestis, it will not allow it to colonize easily or efficiently in this midgut, so the flea will actually be able to do its blood meal. So it won't jump and bite as much, or at least in theory. So one of its virulence factors for social spread is actually colonization in, or specialized colonization for a very specific area of the flea. So we don't even have to worry just about how it infects cells or evades immune system, but we also have to worry about the flea, the lowly flea, on virulence factors in the flea that will help it spread. It's a fascinating example of zoonotic necessity of virulence factors. So, gut is back full of bacteria. We have hungry fleas. Now, I do want to mention, one thing. After this cycling through rodents and fleas, humans can also start getting an overinfection that will cause coughing and spread through the air. And that's called pneumonic infection. That's probably the most dangerous because we have the fastest reactions or spread, and then also the spread through what we call buboes. And buboes are these painful raised lymph nodes where you can have this purplish raised, very, very swollen lymph node, usually in the groins, back and knees, neck. You'll have these headache, chills, and weakness, and then you can have this very high mortality rate, 66 to 75% mortality without antibiotics. After we had antibiotics, we lower it to a lowly 8 to 10% mortality. That's with the best medical treatment that we have. So with the bubo, we usually have 2 to 10 days to death. Then we have something called the Black Death. So we have the bubonic plague, we have the Black Plague, and sometimes they're synonymous. You can get one and then get the other. Buboes and then a Black Plague, or vice versa. Basically, this means that you're having bleeding underneath the skin. This bleeding underneath the skin will cause swelling, purpleness, and even blackness. And then you also have necrosis, thus the Black Plague. This is basically meaning that the Yersinia pestis has gone septic, and this is an extremely dangerous infection. So you're going to be weak. You're going to have abdominal pain because you're bleeding out into your peritoneal cavity, bleeding under the skin causing the blackness, and necrosis of tissues causing the blackness. And then you can have the buboes as well after this or before this. So it kind of depends. You could have the bubonic plague first and then get the Black Death, or have the Black Death first and then the bubonic. But usually when you get to the Black Death stage, the death is very soon after. So you can get it through the flea bite or direct infection through uh, dead people, actually. Finally, the pneumotic plague is the most dangerous. It's spread by air, and basically these lungs are completely full of the infection. And I'll show you a histology picture after this. Bloody mucus, basically you're coughing up necrotic pieces of your lung. You can't breathe, and it is very quick deaths. You're coughing up and exposing everybody in the area to your Yersinia pestis, though. 24 to 48 hours to death, very quick. There are descriptions in um, the main plagues in the 1300s where you would have breakfast with a person, and by dinner they were dead. When you get pneumonic plague, that's a 90% mortality rate. So most people die of this because by the time they have symptoms, it's too late to save their lungs. Madagascar has almost yearly outbreaks of bubonic plague, and the last couple of years they've had pneumonic plague, which is considering we can have spread throughout the world in less than 24 hours. We are painfully aware of that now. Uh, Countries to Africa or flights to Africa from Madagascar and the world are very carefully monitored, and they'll shut down air traffic to Madagascar really quickly. So we still have the Black Death. We still have pneumonic plague. We still have bubonic plague nowadays. Here is a histology slide of alveoli of the lung. And this pink here shows the alveoli sac. It should be empty. What we have are red blood cells and lots of macrophages and the actual bacteria here. So this person has hemorrhaging of the lung. I don't even think you can really mention it as hemorrhaging of the lung because there's so much blood outside of the blood tissue or the blood vessels that it looks like a blood vessel. So this person is clearly going to die because of or probably is dead actually, of the influx of macrophages, blood, and bacteria. So this is a complete breakdown of this. This is still found today. This map is not as recent as I would like, but it is found in the U.S. as a constant. When I was taking my West Nile virus surveillance courses in 2002 to learn how to detect it in Fort Collins, we had public health officials from the Four Corners area that got beepers. Yes, it was that time. Their beepers went off and they had to leave the training to go back to the Four Corners region because they were having an outbreak of the plague. It turns out that rodents such as prairie dogs will, in their colonies, hold these and spread Yersinia pestis. Now, the thing is they are quite willing to colonize campgrounds and such like that. So once in a while, we will have too close of an interaction with humans and cause this outbreak. So they have to have a regular killing of the prairie dogs in the area or the rodents in the area in order to make sure these humans are safe. But this is the Four Corners region is our major outbreak area. People who travel, if you get Yersinia pestis, the first thing they'll ask is if you've been to the Four Corners region. And if not, and we have starting an outbreak in, say, other places, they're going to assume it's a bioterrorist attack, um, or at least be very cautious and start testing them as such. This is where the normal outbreaks are, and the larger the dot, the more common or larger outbreaks there are. Look, Madagascar. It is still very common today. So we have to be very aware of this and vigilant on this infection. And I will end this one.